Hello, everyone, and welcome to today's JMP Academic webinar, JMP for Teaching Statistics in Life Sciences. I'm Ross Matusalam, a JMP Academic Ambassador. I'm just here to host and manage the Q&A today. My colleague and fellow Academic Ambassador Kevin Pochner will be presenting, and he'll review for us a range of tools and resources for teaching core biostatistics methods in health and life sciences education. So if you don't already teach with JMP, today's webinar should help you decide if it might be the right tool for your course. And if you do already teach with JMP, you'll probably still learn some tools or techniques that you didn't already know about, and that might make your course even better. So before we dive in, I want to point out that you can ask questions at any time throughout the Q&A. I will be in the background answering questions as they come in, and Kevin will probably take a few questions live throughout. Whenever you want to ask a question, please do use the Q&A panel in Zoom. And you can see the icon to open up that panel right there on the slide. Feel free to use the chat to post just general comments to everybody. But if you would like to specifically ask a question, please do put it into the Q&A, which helps us better manage the questions and determine which have already been asked and answered. So with that, Kevin, I think we're ready to talk JMP for Statistics in Life Sciences. Are you ready to take it away?
Yes, thanks, Ross. I'm ready to go. You can see my screen with the journal.
Yeah, we can see it, Kevin. Sorry,
Okay,
it was
perfect.
the Zoom unmute button disappeared for me for a second,
Okay.
but we're good. Yeah, have at
All
it.
right, excellent. Okay, as we do in all of these sessions, I'm going to open up a bunch of different data sets. And for each one, I'm going to show some tools and capabilities in JMP. There's a lot to do. I kind of set up a lot of data sets. So I'm going to just, well, it never gets old saying this. I'm just going to jump right in. Okay, so the first topic I want to cover is the visualization graphic capabilities of JMP. I think this is one of our I don't know. I think this is one of our best features is how we create and interact with graphs. So I'm going to start with that. So this first data set is data that was obtained from the Department of Agriculture, where basically for a bunch of states, I think there's 31 different states, so not all of the states, for from 2000 to 2017, we have data on how many acres of corn, soybean, and wheat those states had planted. So each row is basically a state for a given year. Now, in addition to these three variables, what I actually did is also created these four variables. This one here is total acres planted, so that's just summing them all up. And then these ones here are the percentages of that particular commodity per total acres. If you haven't created a new column via a formula yet, let me just quickly show you how to do that. So let's imagine this total acres planted doesn't exist yet. So if you're creating a new column in JMP, and I'd give it a name, so I already have it, so I'm gonna not actually run through the whole thing, but let's say just total acres. And then under the column properties, you open up the formula editor, and this window appears, and you can create a whole bunch of different formulas. Over on the left are some of the traditional things you're going to do, like some conditional statements and such, is probability distributions, row functions, numeric functions. Well, this one's going to be pretty simple. I'm just going to do acres planted for corn plus soybeans plus wheat. So there's my formula. Down here on the bottom, you can actually hit this preview button. This just gives you a chance to look at it to make sure you wrote the formula correctly. I mean, this one's pretty basic, but sometimes it's a little more involved, just to make sure. And then if I hit OK, I'm not going to do that, but it would create that new column, which is the sum. Now, because there are certain formulas that you're going to use very frequently, we actually makes it a little bit easier. So another way to do it is you just grab the three columns that you want to sum up, you right click on it, and you'll see in this drop down menu, new formula columns, and there's all things I could do here. And so one of them is I'm going to go combine. And then if I hit sum, I'm not going to do it, but it would basically create that this total acres planted column. Let me just delete this one that it actually set up. And then you're basically doing the same kind of thing to create those ratios. Okay. So the first graph I'm going to make is a map. And so I'm just going to open it up first so you see where we're going. So this is the graph that I'm going to make here. And it's a map of those 31 states where the color coding is the variable that I'm going to plot, which is like acres planted of the different commodities. And then I have this thing here called the data filter, which is where I'm going to pick a year. So I'm going to create this particular graph. I'm just going to slide it over. Okay. Now, even though there's graphs everywhere in JMP, every analysis you run comes with a whole variety of graphs and visualizations. We sort of pride ourselves on that. We don't think there should be a statistical analysis without something graphical coming up. But if you're just creating a graph independent of a particular statistical analysis technique, you open up the graph builder and just think of it as it's a blank canvas. It's just waiting for you to make this graph. And so if I grab the state variable and drag it into the center of the graph builder, well, JMP knows, well, those are state names, so I'm going to make you a map. If they were country names, then I would see a global map. Actually, this even works if I have counties. So if I had the counties of all these little states, you would see this map, and then you would see little outline boxes for the actual counties. Now, no variables being plotted there. I've got to do that. So I'm going to grab this total acre, the acres planted for corn, and I'm going to make it the color variable. And JMP starts off with just there's a default that your preferences will have and the color it uses and how it divvies up. But you can click on this and change some things. So for example, I can go in here and pick a different color theme. I can even make my own color theme. You can have settings for the gradient. So for example, you can pick, I'm going to put it on a log scale. My favorite is I like to put it on the quantile scale, because then when you do that, now I'm going to hit OK. Then when you do that, the 50th percentile, the median, becomes gray, and then everything below that is blue, and everything above that is red. So I tend to do that, but just letting you know, you can pick all sorts of scales there you want. Now, this is just one of the variables. Now, I can go and create another map just like it for the next variable, and another one for the next variable, and another one for the next variable, and so on. But what's great about JMP is, and this thing I'm about to show you, you can do everywhere, not just in the graph builder, but I can pull up this tool called the column switcher, and I'm going to say, well, this variable acres planted corn, I want you to let me swap that out with all the others. And I'm choosing the acres corn too, because I don't want to lose it. You hit OK. And then over here on the left, I can then choose whichever variable that I want to use for the graph. Okay. Now, remember the data, this data is from 2000 to 2017. So what's being plotted right now is the average of all those years. And maybe I want that, but probably more likely what I want is I want to look at this for individual years. So what I'm going to do is I'm going to bring up something called the data filter, the local data filter, and I'm going to pick year. And so now over here, I can ask to show the data only for a specific year. So think of every combination of which variable do I want to use as the colors, and then how do I want to subset the data, either individual years, or I can even grab a group of years. And then if I grab the group, it's going to use the average. Okay, so that's one graph that I want to show. This, I feel like this kind of comes up a lot in health sciences, because this data could be all sorts of things like health outcomes in counties or states. And so, or, global data on health outcomes, that I find the map is pretty common in the health sciences. All right, so I'm going to close that up. Okay, the next graph I'm going to show you is this graph here, which is a time series graph. Now, it looks a little crowded at the moment, but I'm going to show you what I'm going to do to why I set the graph up this way. But basically, this is where I can use any variable I want, just like before. It's a time series graph. And then I'm going to show you what I'm going to do here with this data filter. Okay, so I'm going to slide this. I'm going to slide this off the screen, but just so you know, that's where we're going. So again, graph builder. I'm going to put year on the x-axis. And I'm going to put that first variable, acres planted, on the y. Now, if I use the connect line, right now that line's going through the average. And so basically, for each year, you're getting all the states in there. Okay. Now I can set up the data filter just like I did. I'm sorry, the column switcher, just like I did before. So this is what's going to allow me to pick any variable that I want to plot. And then what I'm going to do is now for the data filter, I'm going to pick region and state. Okay, so we have different agricultural regions of the country. Now I'm going to grab state and I'm going to put it as an overlay variable. Now, when you see this, it's going to seem like it's incredibly crowded. But now what I can do, now that I have this set up, I can decide whatever variable I want to plot and then whatever part of the country I want to see on the graph. So for example, if I just want to see the states in the Southeast, I can click on this and now there's 4 states in the Southeast and I'm only looking at those 4. So I can come over here and pick regions, or I can, maybe I want to pick little individual states or sets of states. And again, I can switch every variable. So what I'm trying to get across here is the way JMP works is you don't have to think that you're making a graph and you make a graph and then you think of what else you want to plot and then you make another graph and so on and so on. You basically set up this graph. So it's like everything that I might want to do, I'm going to set it up and then just choose it. I just saw in the Q&A, someone asked about the column switcher. So when you're well, in this case, I'm making a graph and you go down on the red triangle at the bottom, you'll see redo and then column switcher. And that's how you launch the column switcher. And then once you do that, it's going to show you, well, these are the variables you're currently using in the graph. And then which one do you want to swap out with? And then you just pick them. And then when you do that, this control will appear here on the left. Okay. The last one I'm going to show is something called the bubble plot. Now, instead of showing it to you first, I'm actually going to make it. I'll leave it as a little bit of a surprise. So I'm going to create this thing called the bubble plot, which is basically a scatter plot. And just to pick something, I'm going to pick corn on the y-axis and percent soybeans on the x-axis. I'm going to put region and state as my ID. Year is time. I'm going to make the bubbles, I'm going to color them by the region. And then I'm going to actually make the size of the bubble is the total acres planted. And I'm going to hit OK. And then I'm just going to turn on a few little controllers that I like here. I'm going to turn on the trail lines. And I'm going to label them. So now it's got these labels. And you can move these around if you want. Okay, so basically right now there's a scatter plot of percent acres corn versus percent acres soybean for 2000. And each bubble is the region. Well, if I hit play, now it's just going to index the scatter plot by each year. So now I can watch the motion. Okay, so now because I have both region and state, if I pick a region, like I just picked the Northern Plains right there, I can hit split and then it will just pull those apart. So now I'm looking at individual states. And so I can grab, or I can grab all of them if I want and split. And then now I have all the states. Now, I'm not going to do it just for the preservation of time, but what I would probably do here is, well, one is I'd probably do the column switcher in case I wanted to plot other variables on the X and Y axis, right? Like the wheat, percent wheat. And I would open up the data filter with region and state. So this way I can decide if I only want to look at a few states or many states or certain regions. And then I've got sort of this master graph, so to speak, that I simply can decide which states or regions I want to look at. but for the preservation of time, I won't do that. But again, that's redo column switcher and then local data filter. Okay. I see someone asking about the motions. If you save this out, then you can save out the graph, and then you can actually play that. Oh, Ross, maybe you could send that person to. We have a one-page guide, I think, that gives instructions for that. Okay, so I'm going to move along just because we have so many topics here. Go into some one sample inference, means and proportions. Those are very very common in a lot of intro stat classes, regardless of the discipline, but certainly for life sciences. So what I'm going to do, this first one, I'm going to open up. Here is this data set actually is one of our enhanced data sets. And if you click on these links that are in the journals, this is going to send you to not only where the data set is, but a description of this data, a little context, some background, some storyline, description of the variables and exercises. So if you go to that link, it will send you, you can get the data and that PDF document. Okay, so what this data set is about is it has a group of children who are testing if they can open up a package that's designed, hopefully, so they can't open it because it's meant for pharmaceutical drug products. And so they have a whole collection of children, and each child actually has an attempt at 4 different package designs, package design A, B, C, and D. And the outcome variable over here is yes or no, they were able to open it. So you can see there are some that were able to open it. Most of them were not. Now, what I want to do is just inference on the proportion of children that were able to open the package or not. But I've got 4 different designs. Now, when you're doing a univariate analysis in JMP, you open up this platform called distribution. Now, I'm going to put the variable that I want to use, open, that's that binary variable, yes, no. Now, if I just hit OK right here, it's going to just basically aggregate all the package designs together. I don't want to do that. So JMP has this neat way to run the same analyses for different groups. And so we basically specify what's called the by variable. So if I put the design here as the by variable and hit OK, what I'm basically going to get is I have an analysis for the data from design A, design B, design C, and design D. Now, this variable open is a binary variable. And so what JMP will do with basically any analysis is it starts off with some initial output. And here we see we've just got some bar charts and some counts and percentages. And then you start dropping down the red triangle to do other things. So for example, just to illustrate, I'm going to add a confidence interval. So I'll add a 95% confidence interval. And then so now you see for each one, I've got a 95% confidence interval estimate of the proportion of children that will be able to open or not open each of those packages. If I wanted to do, let's say, a hypothesis test, I could do that. And so that's test probabilities. Let me make this little report window a little bigger so you can see it all. So now it's been added over here on the right is where I'm going to specify a null alternative hypothesis for each of these designs. So let's say, I'll just make something here. Let's say that we're hoping that, I think actually in the description, I think it's 85% is actually the criteria, which kind of actually surprises me, but I feel like it should be higher than that. But I can test that the proportion of children that will not be able to open the package is greater than 85%. Now I can do that by looking at the confidence interval. We know, like for example, I know that one is over 85%, but I'm just doing this so you can see how to do the hypothesis test. And then I can specify the alternative, and I'm going to do it as greater than, greater than, greater than. And then as I hit done on each of these, now I have the results of a one-sided test of a proportion being greater than 85%. So I got the p-value. There's only one of them, this design C, that didn't meet that criteria. Okay, now just again, I'm moving on just because there's so much to cover. And if you have a numeric variable that you want to do univariate analyses on, like this data set here, you're going to use the same platform. Now, what this data set is about is basically some soil samples were taken, and then some chemical components of those soil samples were measured. So we have a collection of outcome variables. They're all numeric. Oh, I don't know if any of you know this little feature, but see this little tiny, it looks like a little sideways bar chart up there. I know it's really small, but if you click that, it basically opens up a little, basically a column header, which is, in this case, numeric variables. It's going to show a little histogram and shows me the min and the max. I often have that open when I'm working with data, just because I feel it's nice to have a view of it. And then over here where you see the capital sigma symbol, the sum symbol, if you click on that, then it'll actually give me the mean and the standard deviation and the median and the sample size added to that. Okay, so just two little features to help work with data better. So if I go distribution and if I put them all in, I'm basically going to get a univariate analysis for each one. And just like I was showing you in the example with categorical data, binary data, well, there's an initial set of output, like we're seeing here, histogram, box plots, some summary statistics. The default here actually also shows a confidence interval. You can change those defaults if you want. And then you just start dropping down the red triangle to do other things. So for example, just to pick something, let's say I'm going to test the mean, and I'm going to just kind of pick something here. I'm testing the hypothesis that the mean is 2000 or not. So this is magnesium. So hit OK. And then what's going to happen is now this little piece gets added to the output next to that one. I could do that for the others, but I'm just picking one. Now here's another red triangle. I'm just going to click on it to see what's there. These are fun. And we have a bunch of these in JMP, but we have these little animated tools for teaching. So I just opened this one up is to explain what a p-value is. And so this allows me to, in this case, I'm playing around with the null distribution. This line here is where the mean is from the data. And so the shaded regions are the p-values, or I can go over here and change the standard deviation, change the sample size, and help students understand the concept of what a p-value is. And you may have noticed when I drop that down, we also have one for power. So here, if you want to explain to students what a type 1, type 2 error is and power, and you can interact with the graphs or come over here and change values. So we have a bunch of those tools. In fact, there's a webinar that focuses a lot on those teaching tools in our webinar library. So you can get a whole webinar focused on all those interactive tools. Now, I'm just going to do maybe one more thing just to show you. I'm going to fit a normal distribution to this data. So I fit normal distribution. And so actually, you know what I'm going to do? Let me just close up all the other ones so I can just, this is handy because as you keep on adding, as you keep on adding an analysis to your report, it gets the report larger and larger and larger, but every one of these little tables you can open and close, and just helps kind of organize your work. Okay. Now, so what I did is I fit a normal distribution to this data, adds that to the graph. I get some information over here, like the estimates of those parameters. Oh, here's another red triangle. Let me do a goodness of fit test. It adds that. Let me, I'm going to bring up I'm going to bring up an interactive graph. Whoops. I'm going to bring up an interactive graph of the cumulative distribution function. I just added that there. So here I can move this around. I got my estimated cumulative probability with a confidence level around it. So I just did a bunch of things. Okay. Now this is new in JMP 18. You'll see at the top of the headers of different analyses, you'll see this little box and a star. Well, these are called presets. So I can click on this, and what I can do is, now JMP will have some default presets, but let's say this is something you do all the time in your class. Okay, I fit a distribution, I do a goodness of fit test, whatever it is. You do a whole bunch of augmentation to the initial output that JMP provides. Well, what you can do is you can save this as a preset. And so you basically give it a name, whatever you want to call it. I'm not going to do this, but then you save it. And then the next time you do a similar analysis, you would just drop down this preset tool and then select that preset, and then all of that output will just appear. So what you saw me doing is I kept on going under the red triangle and saying, oh, I want to add this, and then going under another red triangle and say, I want to add this, and another one, I want to add this. So you may add 4, 5, 6, or 7 different things. And if this is something you do all the time and you want your students to do all the time, like checking assumptions and all of that, well, then you can just save those as a preset. And then right when you run it, then you can just drop down the preset menu and select it. And then it will do all of those follow-up analyses that you had done. That's a new in version 18. All right. Moving along. Okay. I'm going to go to some two-sample inference. And I'm going to pick, let's see which one I'm going to do first. This is actually one of our case studies, this smoking and lung cancer. So if you clicked on that, you'd actually get sent not just to the data, but our case study about this data. The reason why I'm picking this one, so this is a binary outcome. In this case, it's about a patient having cancer or not, and whether they are a smoker or not. JMP allows you to have the data summarized in tabular form like this. So it could be that each row was a patient, and then I have, what's the outcome? Were they a smoker or not? And in this case, I would have, well, whatever, 94 plus 55 plus 27 plus 63. I would have all of those rows. Now, that's usually a better way to have the data, because then you might have all sorts of other information attached to those patients, right? Their age, maybe their gender, different health habits and other characteristics. But just want to show you that you can do analyses with the data summarized like this. And so basically, I am going to launch this tool called Fit Y by X. And this is what you do when you're doing a bivariate relationship. And so you put the outcome, which is the cancer, no cancer, as the response. My X factor is whether you smoke or not. And then frequency is the count. And I click OK. And well, I gave it a categorical outcome and a categorical explanatory variable. So JMP is going to do a chi-square analysis. So there's an initial set of output like everything in JMP, and then you drop down the red triangles to get more. So I know if you're teaching chi-square analysis, I know a common thing is you might want to show students like, okay, well, how does a chi-square test statistic work? Well, I can add to this table if I want. Well, let's add what's the expected value for each of those if the null is true? And then what's the deviation from that expected value to the actual result? And then what is that contribution to the chi-square statistic? So for the purpose of teaching, you may choose to select different metrics to put on this table. Usually if you're teaching, you might be putting more. If I go to the top red triangle here, this is where I can get other output, like, for example, oh, a 2-sample test for proportions. So I click on that, that gets added down here. This feature actually lets you sort of pick, do I want to have, which way do I want to do the subtraction, cancer or non-cancer? You can pick that. Now, my favorite when it comes to doing proportions, I never liked this because it was always weird to interpret it, right? Because you might say that, oh, something is 20 to 40% bigger. And you're like, well, it's not really that percentage bigger because it's actually, you're looking at the delta between the two percentages. It's not really a percentage. So what I like to do when comparing percentages are things like relative risk. So this is where it's looking at the ratio of the proportions. Then you're actually talking about percentages. Now, JMP lets you pick what do I want to use as the comparison, or I can say calculate all combinations. And then when I do that, I'm basically going to get every possible combination of what ratio, as you can see here, cancer given no divided by cancer given yes, or cancer given yes divided by cancer given no, or no. So you get every combination there. I like these because then when you talk about percentages, it actually truly is that. And there's others we have here, like you can do odds ratios. So I can add an odds ratio there. Risk difference. So there's looking at the subtraction of the two risks, which is basically the same thing as a difference in proportions. So the thing to understand and have your students understand is when you run an analysis like this, you're going to get an initial set of output, and then you drop the red triangle to start running more follow-up analyses and adding to the report. And I'm going to move through these quickly just because of how much we have to cover. Oh, and I don't have anything after this webinar. So if anybody wants to stay on and talk about some more things, or they have more questions, I'll be happy to do that after we get to the top of the hour. I don't have anywhere to go. Okay, this next data set I'm going to open. This is one of our enhanced data sets, and this is from an ecology professor from the University of Georgia that took a collection of monarch butterflies, basically cut it all up into little pieces there, and measured a bunch of characteristics of those pieces. And the purpose was to compare male and female monarch butterflies. And so I'm going to open up the data set, and so you'll see. All right. And so we have here a whole bunch of different variables on things like the size of these parts and the weight of them. They also have information about like the color, the hue of the orange and black. And so we have all of these outcome variables, response variables, and the comparison I want to make is between male and female. Oh, I don't know if you've seen this. If you notice the data sets I use, and I like to do this when I'm teaching, is I always like to have a data set that has a lot of variables, because then I can demonstrate with one of the variables. Like in this case, if I was doing it in class, I could say, well, I'm going to demonstrate with just this total wing area. And then you leave it up to the students to do the rest. And then what I find is nice is then you can do all these comparisons. You can be like, oh, these variables, something was significant, and these ones, they're not, or this one had an outlier. And then it's all part of the same story. So I like to work with data like this. Now, I'm actually going to start off by plotting the data in the graph builder first, and you're going to see why I'm going to do this. So I'm going to put one of the variables in against the two. Oh, I should show this. Do you see over here in the data table, do you see those little blue and red dots? Those are called row states. I'm going to turn those row states off. Well, what I can do is I can add a row state to select rows, and then it tells JMP how to treat that row. And so a common thing that's done is, well, I want to color the data by that row. Now, JMP picks a default, but I can right click here and pick different colors or markers. And then so now every graph I make going forward is going to use red for female and blue for male. Now, because I want to look at all the variables, I'm going to do that whole column switcher thing again. And so this is what allows me to just move through all the variables in one graph. And what I can do, there's some basic analyses you can actually do from the graph builder. And one of the things I can do is this option right here is where it adds a mean and the confidence interval for the mean. And so now not only do I have just a plot of the data, but now I can see the mean and the confidence interval for the mean. And I can do some other things like let me add the mean and the standard deviation. So now I've added that to each group. I can click here F test, and then so up here at the top, now I have basically it's a two sample t test. In general, it's an F test. But basically now I've got a hypothesis test comparing if those means are the same or not. So there's things you can do actually in the graph builder, some basic analyses. But if I wanted the full set of analysis that would come with doing comparisons, I'm going to launch the fit y by x. Okay, I'm going to put one of them here. X is my x. Okay. Now it starts off with that same kind of graph, but remember, here's my red triangle. And let's say I wanted means ANOVA. And then now I'm going to get that classic output, right? The ANOVA table. There's some confidence intervals there as well. And then if I want, pull up my column switcher, and then that's what allows me to just swap and look at whichever variable that I want to see. What you're going to notice with JMP, if for those that aren't currently using it, is compared to other software, what you'll find, and hopefully you're picking this up right now, is you don't actually have to create as much output. You might only have 2, 3, or 4 pieces of output, but you've set them up like I'm doing here with this graph builder, where I can make any graph I want, or if I'm doing, oh, sorry, that one's the full one, or I can do analyses and have the column switcher data filter. And you don't have to just be overwhelmed with saving all these different analyses for every combination you want to look at. You just sort of create this master version of it and then filter and switch the variables any way you want. And so you'll notice it's so much easier to manage your work, because you'll just have a few pieces of output that you work from. So think of output not as a static piece of output, but as an interactive platform that you do further analyses with. Okay, I'm gonna keep on moving. Again, I'll hang out afterwards if anyone wants.
Can I interrupt you just once, because there is a question that came in that you should be able to answer in about 10 seconds. Could you please show us an example of a combined analysis in fit y by x there? So let's say you wanted to look at the effect of both sex and, let's say, thorax or something like that on that total wing variable.
Okay, so if I want to do, so everything I've been doing is so far is just this bivariate analysis. I think this is the question, looking for a regression model with multiple variables. If that's the,
I think so, yes. If you could just show us how to set it up quickly.
Yeah. So if I go into, there's a general tool, which, by the way, I can always go to this fit model. That's something you've got to decide as a teacher. Do you want to just send your students all the time to fit model? Because I can do simple regression or multivariate regression all from this, where the fit y by x is only designed for doing single variable models. And then the fit model is for multi, but you might decide, okay, let me just send them to this one. So let's say I was trying to do something like predict total wing area, and I wanted to say, look at the variable sex, and I didn't know what, well, I'll pick weight just to pick something. Then I can go in here and I'm going to say factorial to degree 2. And then this is going to fit a regression model, a multivariate regression model that has both sex, live weight, and the interaction between the two. And so now I'm fitting a multivariable regression model.
Great. Thanks, Kevin.
Yep. So again, I know some teachers they don't want to overwhelm students with the general platform. So if they're doing simple regression, they're like, oh, let's just use y by x, and there's less stuff you'll see and less options. Okay, and the last one I want to show in here is, because this kind of comes up a lot in life sciences, where is it? Oh, is matched pair analysis. So this is another one of our enhanced data sets. And basically a researcher did this experiment where they had dogs see their owners interact with other dogs, or interact with an inanimate object, and try to see, is the dog exhibiting jealous behavior when they see their owner interact with another dog? And so what that data set looks like is there's 18 dogs in the study, and basically the outcome variable is the amount of force that the dog is exhibiting. So they have the dog on a chain, and so when it goes forward, it's obviously going to create a force. And so they're measuring the amount of force when the dog sees its owner interact with a dog or this inanimate object. Okay. Now we know with sort of this matched pair type analysis, we could also just create a column, which is the delta between the two, and then do a one sample t-test, right? Testing if the mean is 0. But I'm going to show you the tool in JMP to do it as a matched pairs. And that one is under this specialized modeling menu. You see matched pair. And so you basically put in the 2 outcome variables, which in this case is dog and cylinder, and I click OK. And so this is what this report looks like. So here's the results of that hypothesis test, doing a matched pair t-test. Here's a red triangle for other options of ways I might want to view the graph, or other statistics I might want to add. And then this graph is nice. What this graph is doing is it's basically plotting on the y-axis the delta between, I'll make it bigger. It's plotting on the y-axis the delta between the 2 measurements. So it's doing cylinder minus dog. Okay, so I can look at each dog here. The red line and the dotted lines, that's the mean difference and the confidence interval for that mean difference. So it's basically these numbers down here. And then on the x-axis, it's plotting the average of those 2. So it's just it's a nice way to view, looking at all the deltas, but also as a function of the size. And that's kind of common, right? Because when the values are larger, then obviously, and then the deltas will become larger with it. So it's a nice way to view that graph. And again, if you were teaching this in class, you might decide, have your students, well, let's do a one sample t-test on the delta between the 2, and you'll get the same answer. Actually, usually with stuff like this, and I'm guessing some of you do this as well, is I'll often have students like do a 2 sample t-test first, and then, what is that analysis not able to do, and why is that not the correct analysis? Then you go to the correct one. I always like to do that. Okay, moving on. Now, doing a comparison of 3 or more is going to be very similar. So I'm going to open up that child-resistant packaging data set again. Now, before, remember, we did individual analyses for each design, A, B, C, and D, which is fine. I mean, that's a legitimate thing to do, look at each one and maybe compare across. It's not the formal comparison test, but I often start that way. But that's actually how I like to teach. I usually like to take the same data set, and as you learn more and more tools, you keep going back to that same data set and say, oh, now that we've learned how to do comparisons, let's go back and not just use it as a bivariable and compare, but actually a statistical comparison. So I'm going to launch the fit y by x. And so again, whether you have 2 categories, 3 categories, or 1,000 categories, fit y by x, it's still, you have one x variable. So I'm going to put, was the child able to open it or not? And then I'm going to compare the 4 different designs. So when I do this, I'm going to get a contingency table, chi-square analysis, comparing across A, B, C, and D. Now, something I like to do here is I'll bring up a data filter, and I'm going to bring in design as the data filter. Oh, actually, you know what I'm going to do? I'm going to bring in, okay, I'm going to be clever here. I'm going to bring in age. I'll bring all these in. Age, gender, and design. Now, what this allows me to do is I can do something like, okay, do this comparison, but only for the boys, or do this comparison, but only for the girls. So the data is getting subset. You can see the numbers changing and the graph changing a little bit, where I'm just picking one of the genders to look at. I could do the same thing with age. So I can either drag this around or type in a number like, well, you know what? I only want to look at the children that are at least 4 years of age, so between 48 and 51 months. Or maybe I want to look at only the children that are between 42 and 48 months. And so every time I subset this data, you see how all the analyses are changing, results are changing. See, this is what I mean about you don't have to have a whole new set of output for every combination of thing you want to look at. You just have one platform and then filter it the way you want. So I can do the same thing with the design. So right now this analysis is on 4 designs, but if I want, I can say, well, I just want to compare A and B, and I can do A and B, or I want to compare B, C, and D. And so each way that I subset the data by design, by the sex, or by age, you notice I can view this analysis results subsetting the data any way I want. So now I just need one of these reports instead of making a separate one for each. Not only do I think that's a great way to look at the data, I think it's a great way to teach, because I don't know, I always felt I learned by watching something change. So I feel like students really learn by, you say, watch what happens when I change something. Now look at the things, the metrics and the graphs, look at how they change. And then I feel that's such an easier way to get a concept across to students when they can see it change like right in front of them as you're, in this case, filtering the data, and they see that effect you're trying to illustrate, whatever metric you're trying to get them to focus on. I just find this just a great way to teach. Now, for the categorical, for the numeric outcome variable, it's the same kind of thing, that Y by X platform. In this case, I'm going back to the soil sample data, but what has been now added is there's different locations they took these samples from. And so I can go in there and basically do a Oneway ANOVA. I'm just going to pick one of them, locations. Again, jump starts off with a graph, and then I'm going to add the results of the analysis of variance. And another thing I'm going to add is I am going to do multiple comparisons. So now you didn't see this, but basically more and more output gets added to this report. So down here are all the pairwise comparisons, confidence intervals. It's doing that connecting letter report. This is fun. Up here, it actually adds this little interactive tool where you can click on a group, and then it's showing you the ones that are statistically different or the ones that are not by identifying it via the color. And so you can actually see that those same results you're seeing down here, but I can interact with it by grabbing them. And again, if I wanted to, I would bring up the column switcher so I can look at all the other variables. And then now, same thing, I can just pick which variable I want, and all of the output will change accordingly. Now, I'm going to do one more comparison, and this one, let's see. Okay. This one is on some genetics data where there's basically, I think this has to do with breast cancer, and there is two types of, there's two treatments, so basically the treatment and the control group. And then there's data that was collected on 12 hours and 24 hours and 48 hours. Let me, I've got those columns hidden right now. I want to change that. Okay. So I basically have 12 hours, 24 hours, 48 hours. So you can see I have 6 different combinations of the treatment and control. Okay, so then I have all these basically outcome variables that are, I'll just move over so you can see a couple of them, right? So I've got basically these markers, and I'm going to see how those outcomes are changing across treatments. Now, I can do this all different ways, which is why I love this whole bivariable concept. So I'm just going to put one of them in there. So if I wanted to, I can say, well, I want to compare across time for each treatment. So then I would get a one-way ANOVA across time for the control group and the treatment group. Or I could do it the other way. I compare the two treatments, control versus treatment, for each time. And so I'll just pick that one to do. And you're going to see I've got 3 pieces of output here, one for each time. And I can do a comparison between control and treatment. Okay, now what I'm going to do is I just want to do this for one time period. So I'm going to hide and exclude the 12 hours and 24 hours. I just want to do this for 48. Now you may have noticed this. I wasn't pointing this out yet, but let's say you go in here and you're all right. So I'm going to do comparison across treatment, get my little one-way ANOVA output. And then you're like, oh, you know what? Well, Kevin showed me this column switcher thing. I got a bunch of other variables. Let's do this. Okay, so bring up the column switcher. Give it a second there. Oh, don't know why I'm hanging. Oh, because there's many variables. That's why. I'm going to swap this variable. All right. So now I've got this column switcher. Well, guess what? I have, you may have saw this. I wasn't drawing your attention to it yet. I have 54,675 outcome variables, right? So sure, this might be fine, and I could go and click through, but this would be a very cumbersome way to go and look through 54,675 two-sample t-tests to find out what's significant and not. Well, JMP has this awesome tool for this. It's called response screening. And what I'm going to do is I'm going to put in all 54,675 outcome variables. Treatment is my X. I'm going to hit OK. Boom. What JMP just did is 54,675 two-sample t-test and has displayed some statistics in this table going from most significant to least significant, right? So I can see the markers that are most significant. I've got p-values. I also have p-values that are adjusted for the fact that I'm doing 54,000 of these. So it's the FDR stands for false discovery rate. So this is adjusting for that I'm doing so many tests. And I'm just going to show this one graph that I like, this one graph that you can add. This is called the Volcano plot. So now what this is doing, oh, and I can even add more stuff to this table if I want. I'm going to right click here. Oh, whenever you have a table in JMP, if you right click on it, this is where you can see what other statistics I can add to this table. So JMP will have a default, but I can add more. So let's say I'm going to add the upper and lower confidence bound, 95% confidence bound, using the FDR adjusted approach. But now what I have here is I have a graph of basically the log worth, which is it's just basically a log function of the p-value. So it's just putting it on better scale. So the higher up in this case, those are the significant ones. And then on the x-axis is the difference, the delta between the treatment and the control. And so I can either grab them up here like this, or I can grab them in the table. And so what I can do is, well, whichever criteria I'm going to use, let me pick something here. I'll pick, let's go, oh, I'll go down here. Sorry, there's so many here. Oh, it doesn't matter. I'll just pick a set. So I can grab a set of these, okay? And then I can say, select columns. Now, if I go back to the data table and I scroll across here, let's see if any pop up. There's only 64 of them, but basically 64 columns are selected. Well, it'd be hard to find them. And then I can say subset the data. Okay. And I can choose selected columns. And then now I can create a data table that is just pulled off those markers that I've identified as significant. Okay. Now, this is a huge topic. And so in the journal that you're going to get, there's a link here that is a collection of, I don't know, it's about 5 or 6 hours of videos of working with genomics data. And basically, as you'll see, there are analyses when you just have so many response variables, tens of thousands, that there's a bunch of tools in JMP that are designed to work with that data. And I just showed you one example where I can ask JMP to do tens of thousands of, in this case, 2-sample t-tests, but it could be ANOVA, it even could be a simple regression, do the thousands of them, and then summarize all the results for me so I can quickly grab the ones that are significant from the ones that are not. And then this link here will send you to a book that we have, an ebook that is showing you ways and tools in JMP to work with and analyze genomics data. So I just wanted to show this and introduce this because some of you might be dealing with this kind of data, and JMP has tools designed for that. So I encourage you to go to those links to learn more. And sorry, this is just a super, super fast introduction. Okay. Close this up. Okay. Now, what I'm going to finish with, and I want to show you this capability. I was wanting to show simple linear regression and logistic regression, but I don't have the time because I want to get to showing you that JMP has the ability to analyze sensor data, like survival analysis data. So this data set is data on 299 patients and categorizing those that had heart failure and those that did not. And there's a bunch of characteristics of those people, as you can see. Well, when a person has heart failure, we have the time at which that has happened, from when they started making this. Basically, there was a characteristic that occurred with these patients. And then from that point, when did they have heart failure? But there's also a bunch that did not have heart failure, and there's by a particular time that we stopped. So this data is censored. Like, it's quite possible these people will eventually have the heart failure. They just didn't have it yet by that time. Okay. So JMP has the ability to build models where you have data that is censored. And so I'm going to open up this platform called Fit Parametric Survival. And what I'm able to do is I'm going to put in the time variable as my outcome. Now, the heart failure, yes or no, that's actually my censoring. And the censor code is no, right? So for the people that did not have heart failure, that time value is a censored value. They may eventually have heart failure, but it's going to occur some number after that time value. Those that have had heart failure, well, that is the true time. And then I can go in here and put in a bunch of explanatory variables. So I've got some categorical variables. I've got some numeric variables. Now I can do interactions and all that, but I'm just going to put just the main effect just so you can see what that output is. I can pick a distribution for the error term. I'll just leave it as Weibull. And then I hit run, and JMP basically just fit a linear regression model, but taking into account that I have data that is censored. And so when it estimates these parameters, it's using a method to take into account that data is censored. Those time values are not all the actual time values, they're censored. Now, this you can do from any model building place in JMP. So it fit the full model. I gave it all these terms, but you can actually, right from here, this is where I can start reducing the model if I want. So I can start pulling out terms that I don't think are significant and ending up with a final model. Now, if you really analyze this data, you'll see there's interactions and all that. I'm just making it super simple just to illustrate this exists. And what I wanted to show is I'm going to pull up two of the profilers. And so now I have these interactive tools that are visually showing me the model. So for this one I'm playing with at the top, I can pick a time and then any set of values for the other explanatory variables. And then I have an estimated probability of that particular patient with those characteristics having heart failure by that time. Or the one on the bottom is I'm picking the characteristics. And then I'm getting an estimated time of the heart failure. Okay, I know that was a lot of with these webinars. It's like we're trying to tease you a little bit and give you an introduction to a lot of these tools. We have an entire webinar library on not only other topics, but that demonstrates some of these specific topics in more detail. So if you want to see more about the one sample, two sample inference or building regression models, et cetera, those videos that I was showing you on genomics data, I would encourage you to go check those out, or that ebook if you deal with genomics data. There's platforms in JMP just designed for those kinds of data. And as I said, I don't have another meeting right after this, so I will be glad to hang out if anyone wants to chat some more or has some more questions. With that, Ross, any outstanding questions?
Looking at it, no, we've stayed pretty well up on the Q&A here, Kevin, but a lot of questions came in throughout, so I think you generated a lot of interest there. But of course, everyone, if you have any final questions you want to ask, as Kevin mentioned, we're going to hang out here for a few minutes, so you still have some time to type those into the Q&A. And while we do that, Kevin, do you want to show everyone where to find the library of teaching resources that we have available for teaching biostatistics and statistics in life sciences in general?
Yes. Okay. So if you just go to our website, my screen's still sharing, right? Yeah, okay. If you go to our website under the menu Why JMP Academic Programs, we've organized our content and our resources. We sort of have it by faculty, student, and researchers. You'll eventually get to the same content. We're just trying to curate a little bit. So I'm going to go to course materials for faculty. And again, we try to curate this a little bit by course, but you can, if you click on any of these, you'll get eventually to all the same content. But again, we're just sort of trying to serve it up to for recommended based on the course. But I'm going to click on biostatistics. That's probably the most relevant. Give it a moment to load here. I do not know why that's going slow. Oh, here we go. Okay. So this is what gets you to, for example, our step-by-step guides and quick how-to videos. These are the kinds of things you want to direct your students to, because they quickly show you how to run analyses in either a printed version or a video. These are case studies. I was using one of those in there, the lung cancer case study. Enhanced data sets, I was grabbing data from here. We have lab activities. If you click on the webinar library. And this is where this recording will eventually go, but here's a collection of webinars. So for those of you who want to see things in more, like, I know there's a question about building regression models, and I went over that in probably 3 minutes, but here's some webinars on that specific topic that you can go and see.